Article 400 within the National Electrical Code specifically addresses flexible cords and cables. Section 400.7 outlines the permissible uses for flexible cords and cables. It's important to note that flexible cords and cables should not be used as a substitute for fixed wiring where raceways or other approved means are required. Flexible cords and cables are intended for specific applications. These include pendants, fixtures, appliances, portable lamps, portable tools, and other situations where flexibility is a necessity. Section 400.9 covers splices. Splices in flexible cords must be made using approved methods. Splice connectors need to be insulated with an approved insulating material, ensuring that the insulation of the cord is restored to its original condition. Section 400.12 focuses on cord reels. Cord reels must be designed and installed to prevent tension on the cord from causing damage to the cord itself or to its connections. Section 400.14 discusses plug caps. Plug caps must be of the grounding type when they are used on grounding type cords. Section 400.41 addresses strain relief. Flexible cords should be secured to electrical equipment in a manner that prevents strain on the terminals and avoids the loosening of connections. A strain relief clamp can be used to achieve this purpose, providing adequate strain relief. Now, let's consider additional guidance from other sources. OSHA 1910.305 mandates that flexible cords and cables be used in a manner that minimizes their exposure to mechanical damage, helping to ensure their longevity and safety. ANSI/UL 62, which pertains to flexible cord and fixture wire, provides specific requirements for cord drops. These include strain relief requirements, which are crucial for maintaining the integrity of the electrical connections. Moving on to recommended practices. Firstly, use cord grips that are specifically designed for the type of cord and cable that you are using. This ensures a proper and secure fit. Secondly, install cord grips at the point where the cord enters the enclosure or box. This provides strain relief at the entry point, preventing damage to the cord. Thirdly, ensure that the cord grip secures the cord firmly without damaging it. The cord grip should provide a secure hold without compromising the integrity of the cord's insulation or conductors. Fourthly, use a strain relief clamp or other approved method to secure the cord to the equipment. This provides an additional layer of protection against strain and potential damage. The National Electrical Code does not explicitly address the use of cord grips for cord drops. However, the practices we have discussed are highly recommended. Implementing these practices ensures the safe and proper use of flexible cords and cables in your installations. Always prioritize safety and adherence to best practices when working with electrical systems. The purpose of these guidelines is to mitigate any potential hazard associated with flexible cords. By following these guidelines, you can create a safer environment. When selecting cord grips, consider the cord's diameter and the environmental conditions where it will be used. Cord grips are available in various sizes and materials. Some are designed for wet locations, while others are suitable for dry locations. Ensure the cord grip is compatible with the cord. Choosing the right cord grip is crucial for maintaining a secure and reliable connection. Another aspect to consider is the installation of the cord grip. It should be installed correctly to provide adequate strain relief. Over-tightening the cord grip can damage the cord, while under-tightening may not provide sufficient strain relief. Follow the manufacturer's instructions for proper installation. Regularly inspect cord grips to ensure they are in good condition. Look for signs of wear and tear. Replace damaged cord grips immediately. Proper maintenance of cord grips can prevent electrical hazards. The use of flexible cords is common in many industrial and commercial settings. They provide flexibility and convenience. However, it's important to use them safely and in accordance with applicable codes and standards. Failure to do so can result in electrical shock, fire, or equipment damage. Always disconnect power before working on electrical equipment. This is a fundamental safety precaution that can prevent serious injury or death. Use appropriate personal protective equipment (PPE). PPE may include safety glasses, gloves, and insulated tools. Following lockout/tagout procedures is also essential. Lockout/tagout ensures that equipment is energized and cannot be accidentally turned on during maintenance or repair. Understand the electrical system you are working on. Know the voltage levels, circuit protection, and grounding requirements. If you are unsure about any aspect of the electrical system, consult a qualified electrician. Electricity can be dangerous. Always exercise caution and follow safety procedures. Proper training and experience are essential for working with electrical equipment. Ensure that you have the necessary qualifications before attempting any electrical work. Continuing education can help you stay up to date on the latest codes and standards. Electrical safety is a shared responsibility. Everyone who works with or around electrical equipment should be aware of the hazards and precautions. Encourage a culture of safety in the workplace. Report any unsafe conditions or practices to your supervisor or safety manager. By working together, we can prevent electrical accidents and create a safer working environment. Flexible cords are often used for temporary power distribution. For example, they might power temporary lighting or equipment during construction or maintenance. When using flexible cords for temporary power, ensure they are properly supported and protected from damage. Avoid running them across walkways or through doorways. Use cord protectors or cable ramps to prevent tripping hazards. When coiling or storing flexible cords, avoid creating tight bends or kinks. This can damage the conductors and insulation. Use a cord reel or wrap the cord loosely. Store cords in a dry and protected location. The environment in which flexible cords are used can affect their lifespan. Exposure to extreme temperatures, moisture, or chemicals can degrade the cord's insulation and conductors. Choose cords that are suitable for the environment in which they will be used. For example, use oil-resistant cords in areas where they may come into contact with oil or grease. Use water-resistant cords in damp or wet locations. Ultraviolet UV radiation from sunlight can also damage flexible cords. If cords are exposed to sunlight, use UV-resistant cords or provide shading. Proper grounding is essential for electrical safety. Ensure that all equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Test grounding systems regularly to ensure they are functioning properly. Use a ground tester to verify the integrity of the grounding connection. If you find any problems with the grounding system, correct them immediately. Ground fault circuit interrupters (GFCIs) are another important safety device. GFCIs protect against electrical shock by detecting ground faults and interrupting the circuit. GFCIs are required in certain locations such as bathrooms, kitchens, and outdoor areas. Test GFCIs monthly to ensure they are working properly. Press the test button and verify that the GFCI trips. If the GFCI does not trip, replace it immediately. Surge protection is important for protecting electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors divert excess voltage away from sensitive equipment, preventing damage. Use surge protectors for computers, televisions, and other electronic devices. Inspect surge protectors regularly to ensure they are functioning properly. Replace surge protectors after a lightning strike or other major electrical event. Electrical fires can be caused by faulty wiring, overloaded circuits, or damaged equipment. Install smoke detectors in your home and workplace. Test smoke detectors monthly to ensure they are working properly. Have a fire extinguisher readily available. Know how to use the fire extinguisher. If you discover an electrical fire, do not use water to extinguish it. Water can conduct electricity and increase the risk of electrical shock. Use a fire extinguisher that is rated for electrical fires. Call the fire department immediately. Always seek professional help from a qualified electrician for any electrical work that you are not comfortable performing yourself. Working with electricity can be dangerous. It's best to leave complex or potentially hazardous tasks to the professionals. A qualified electrician has the training, experience, and equipment to perform electrical work safely and correctly. They can also ensure that your electrical system complies with all applicable codes and standards. When hiring an electrician, check their credentials and references. Ensure that they are licensed and insured. Ask for a written estimate before work begins. A reputable electrician will be happy to provide you with this information. Communication is key when working with an electrician. Clearly explain your needs and expectations. Ask questions if you don't understand something. The electrician should be able to explain the work they are doing in a clear and concise manner. After the work is completed, inspect it carefully. Ensure that it meets your expectations and complies with all applicable codes and standards. If you have any concerns, discuss them with the electrician. Don't hesitate to ask for corrections or adjustments if necessary. The goal is to ensure that the electrical work is done safely and correctly. Remember, electrical safety is an ongoing process. It requires constant vigilance and a commitment to following safe practices. By staying informed and taking precautions, you can minimize the risk of electrical accidents and create a safer environment for yourself and others. In conclusion, while the National Electrical Code doesn't specifically call out cord grips for cord drops, their use, combined with adherence to OSHA guidelines and best practices from standards like ANSI/UL 62, ensures the safe and reliable operation of your factory equipment powered by flexible cords. Remember to select the right cord grip for the cord type and environment, install it correctly, and maintain it regularly.